Hello and welcome back. So, in this lecture, we are going to understand the visual representation and the use case of RelU activation function. So, here is the visual representation of the RelU function, activation function. So, the basic formula of RelU function is RZ is equal to max of 0 and Z. Okay. So, this is very simple mathematical function basically. If you are talking about this function, then it's very simple. If the input is positive or 0, let it pass through unchanged like an open switch. And if the input is negative, turn it off completely like a closed switch. Okay, so maximum of 0 and Z, whatever is maximum, you need to take it. So if X is smaller than 0, then obviously the RelU value will be 0. Okay, and if the value is positive, then in that case, the value will be that one. Like here, if you put like max of 0 and 20, then in that case, the function value will be 20. But if the value is negative, right, then if there is a negative number, right, then in that case, you need to turn it off. You don't need to use this instruction, or don't need to use this to train your model. Okay. So this is how the simple function, which is a ReLU function, works, but it has a very big impact on the neural network, how the neural network learn the things. So we are going to see a simple use case. So here it has been explained, like what could be a simple use case here. So you can imagine that you are teaching a robot to play a simple game where it has to move a block to a target. Okay. So without ReLU, what will happen? Without ReLU, the robot might try moving the block in a random directions, sometimes moving towards the target, sometimes away from it. So it learns slowly because it doesn't know which movement are helpful and which are harmful. So without the ReLU, training to the model is really tough. To such a model, which is like a robot, right? So training to the robot will become really tough. There is no ReLU because you need to train it again and again, right, through the other methods. And you need to again back propagate the things in a different manner. So it will be a cumbersome process to train it. But with the ReLU, what will happen? The second heading you can see, with the ReLU, what will happen? So ReLU acts like a filter. It only allows positive movements. I mean, those movements that bring the block closer to the target, right? So to have a significant impact on the robot's learning. So with the help of the ReLU function, if the output is coming out like yes, it has moved closer to the block. If the block has been moved closer to the target by the robot, then in that case, you will let it through. I mean, you will accept it. You will accept the movement. Otherwise, you will not accept the movement. So any movement which keeps it away from the target will be negative, and any movement that makes it closer to the target will be positive. In case of positive, you will start moving towards the target, and you will be giving you will be allowing the value to allowing the activation function to accept the value and let it through, right? Otherwise, you will ignore it. So movement that push the block further away are essentially ignored, right? So you can understand that when you can use such kind of activation function, which is known as the ReLU activation function. So in simple terms, ReLU is helping the robot focus on what's working and quickly learn the most effective way to reach the target. It's like the robot saying that movement helped. Let's do more of that, while ignoring movement that hindered the progress. This is a simplified analogy, but it illustrates how ReLU helps machine learning model learn faster and more efficiently by emphasizing positive signals and suppressing negative ones. So I hope you must have understood that how the ReLU is used and when the ReLU is used. And in the next video, we are going to understand about the TANH, another activation function that is also the important activation function. And after that, we will be having some kind of code exercise to use these ReLU and this TANH and the sigmoid functions, how they differ and how you can use them in the code that we are going to see after the TANH understanding. So I hope you must have enjoyed it, and you can put the comments if you like it or not, because whatever I am explaining you, these are all my personal notes. I have not created the PPTs, but yeah, rather than PPT, I am explaining it to you with the help of the notes directly, right? So I hope there is no problem understanding this, because this is simple maths, and the understanding you need to make, like why these functions, methods, whatever you studied in your college days, these mathematical concepts, why they are useful, where you will use those days. You must be wondering, like, when I'm going to use these concepts, where I'm going to use these concepts. So here is the scenario, like machine learning and data sciences came. Now use it, now learn it, and now connect it, and just teach this to your children as well. Like whatever you are learning, this is not like it is not of any use. It has significant use, and that significant use had literally changed the world with the help of the AI and data science. So I hope you are enjoying. We'll meet in the next video. Till then, have a nice day. Bye.